Welcome to Still Science Lab. Tonight, we explore about the terrifying reason CERN needs two Higgs bosons. Human history is fundamentally defined by our relentless pursuit of the absolute bottom of reality. We look out at the staggering, terrifying complexity of the cosmos, the swirling, violent spiral arms of distant galaxies, the crushing nuclear furnaces of burning stars, the delicate, highly improbable chemistry of our own biology. And we possess a deep, instinctual need to dismantle it all. We want to isolate the final, indivisible pieces that make up the physical world. And more importantly, we want to understand the invisible rules that bind those microscopic pieces together into the heavy, solid reality we experience every day. For a brief, intoxicating, and globally celebrated moment in the summer of 2012, humanity collectively believed we had finally reached that ultimate bedrock. We believed we had found the last missing puzzle piece of the universe. Deep beneath the border of France and Switzerland, buried inside a 27-kilometer ring of superconducting magnets cooled to temperatures colder than the freezing void of deep space, physicists forced packets of protons to collide at nearly the absolute speed limit of the universe. They were searching for a ghost. For decades, our most precise and successful mathematical framework, the Standard Model of particle physics, carried a profound and deeply unsettling prediction. It claimed that the emptiness of space was not actually empty at all. It proposed that an invisible, highly active, and pervasive medium permeated every single cubic millimeter of existence, from the darkest voids between the galactic superclusters to the microscopic spaces inside your own body. This medium is the Higgs field. It was proposed as the ultimate cosmic molasses, a foundational presence that all fundamental particles must wade through. As these particles drag against this invisible field, they experience a form of quantum resistance, acquiring the property we intuitively understand as mass. Without the relentless grip of this field, the fundamental building blocks of reality would remain entirely weightless. They would zip through the universe at the speed of light, never slowing down, never clumping together, never forming the heavy atomic cores of the elements. There would be no complex chemistry, no rocky planets, no burning suns, and no conscious observers to look up at the night sky. The sheer physical existence of reality, as we know it, completely depended on this invisible foundation. But for half a century, the Higgs field remained a purely mathematical phantom. It was a beautiful, elegant story written on chalkboards, but completely lacking in hard, physical proof. You cannot photograph a field. You cannot reach out and touch it. The only way to prove that this cosmic ocean truly existed was to strike it with an unfathomable amount of localized kinetic energy, hoping to force the invisible water to shudder to raise a single, fleeting ripple. That microscopic, temporary ripple is what we call the Higgs boson. When the colossal detectors at CERN finally sifted through the wreckage of trillions of high-speed collisions and caught the unmistakable, decaying echoes of that single particle, the scientific world erupted in a chorus of triumph. It was heralded as one of the greatest intellectual achievements in the history of our species. The global media enthusiastically christened it the God particle, a title that physicists quietly despised, but one that perfectly captured the magnitude of the moment. The discovery was the keystone of the Standard Model. It was the final, triumphant confirmation that humanity had successfully mapped the fundamental ingredients of reality. The applause was deafening. The textbooks were rapidly rewritten, and a profound sense of closure settled over the scientific community. We had peered into the absolute dark of the quantum basement and illuminated the mechanism that gives the universe its physical substance. We had found the field. We had weighed its ripple. We knew, without a shadow of a doubt, that it was there. It felt like the end of a grand narrative, the satisfying conclusion to a journey that began millennia ago with ancient philosophers asking what the world is truly made of. But science is a restless, unforgiving endeavor, and closure is very often just a psychological illusion masking a much deeper, more formidable horizon. When the champagne bottles were cleared away and the echoes of that single, monumental discovery faded into history, a quiet, deeply unsettling realization began to take hold in the minds of theoretical physicists. Finding the Higgs boson was not the end of the story. In a very real, mathematical sense, it barely served as the introduction. Confirming that a cosmic field exists is a completely different scientific reality from understanding how that field actually behaves. We had successfully proven the physical presence of the foundation of reality, but we realized with chilling clarity that we knew absolutely nothing about its character. Imagine standing on the shoreline of a vast, pitch-black ocean in the dead of night. By tossing a heavy stone into the water and listening for the splash, by watching a single, fleeting wave roll across the surface and crash against the shore, you have proven that the ocean is there. You have definitively proven that the water is real. But that single wave tells you absolutely nothing about the deep, hidden currents moving silently miles beneath the surface. It tells you nothing about the crushing, terrifying pressures of the abyss or the complex, turbulent mechanics of the ocean itself. The discovery of the single Higgs boson in 2012 was merely the act of throwing a stone into the quantum vacuum. It told us the field was present, and through subsequent years of careful measurement, it told us how the field interacts with other things. We learned how tightly it grabs hold of the monstrously heavy top quark, and how it couples to the fleeting, unstable particles of the subatomic world. Every single measurement we took, every ounce of data we collected, involved the Higgs field reaching out and touching something else. We watched it interact with the rest of the universe. But we remained entirely, fundamentally blind to what the field does when it is left entirely to its own devices. The standard model of particle physics is not merely a catalogue of cosmic ingredients, it is a rigid, deeply interconnected architectural blueprint. And buried deep within the mathematical foundation of that blueprint lies a prediction that is far stranger and far more unsettling than the mere existence of the field itself. The mathematics dictate that the Higgs field does not just interact with the particles of matter and force. It possesses a hidden, almost paradoxical, and deeply recursive ability. The Higgs field interacts with itself. It pushes and pulls on its own presence. This is a concept that aggressively challenges the boundaries of human intuition. When we think of physical interactions in the macroscopic world, we instinctively picture two distinct, separate entities. We picture a solid magnet pulling forcefully on a piece of cold iron. We picture the massive gravitational well of the moon silently dragging the oceans of the Earth into high tides. We picture a photon of light striking an electron and knocking it out of orbit. There is always a sender and a receiver, a cause and an effect passing between two separate players on the cosmic stage. But the foundational field of reality is predicted to be self-referential. What does it actually mean for a field to interact with itself? It means that the strength, the behavior, and the fundamental stability of the field at any given point in space is actively shaped by its own existence. The field acts as both the agent and the subject of its own force. It is a recursive loop of physical reality, a cosmic feedback mechanism operating in the absolute dark. This self-interaction is not a minor footnote hidden in the margins of the equations. It is the absolute core of the field's identity. It defines the invisible geometry, the mathematical landscape that the entire universe rests upon. If the field interacts with itself strongly, the fabric of reality behaves one way. If it interacts weakly or differently than our equations predict, the entire structure of the cosmos, the history of the early universe, and the ultimate fate of reality itself are fundamentally altered. This self-interaction is the master rulebook that governs the vacuum of space, dictating the stability of the very ground we stand on. Yet, Despite its overwhelming existential importance, this foundational property has never been directly observed. It remains a theoretical ghost. It is a dark prediction written in the elegant language of mathematics, but it has never been verified by the harsh, uncompromising light of nature. And this is the terrifying, unyielding limitation of the monumental 2012 discovery. A single Higgs boson, a single, solitary ripple in the field, can never, under any circumstances, reveal this hidden behavior. When you excite the field just enough to produce one particle, the field is responding entirely to the external energy you injected into it. It is not responding to its own internal curvature. A lone Higgs boson, decaying in the heart of a detector in a fraction of a microsecond, tells you about the mass of the ripple, but it is completely, fundamentally blind to the self-interaction of the field. You cannot extract this deeply hidden truth from the easy measurements. You cannot cleverly back-calculate it by watching the field interact with other particles. The single particle, the great triumph of modern science, leaves the greatest, most profound mystery of the quantum realm completely untouched. We are left staring at the foundation of reality, knowing with absolute certainty that it is there, but entirely, dangerously ignorant of the rules that govern it when nothing else is around. To pierce this veil, to force the universe to finally reveal the true, unguarded nature of its most fundamental field, physicists must push the boundaries of experimental science to the absolute extreme. We must move past the era of discovery and enter an era of unprecedented, forensic interrogation. To prove that this self-interaction is real, to measure how the field pushes on its own presence, we must force nature to do something it desperately, fundamentally wants to avoid. We cannot just make a single splash in the pond. We must violently strike the quantum vacuum with such unimaginable, localized concentration of energy that the field shutters, fractures, and folds in on itself. We must force the universe to create two Higgs bosons in a single, simultaneous, and blindingly violent instant. We have to create a double ripple. This is not about producing two separate particles in two separate proton collisions happening side by side in the detector. That would be an accident of timing, a mere coincidence that teaches us nothing new. It is about triggering a single, unified quantum event where the sheer, raw intensity of the disturbance forces the field to invoke its own internal rules. We are looking for the exact moment where a massive disturbance in the field splits and gives birth to two distinct ripples entirely through the mechanism of self-interaction. We want to catch the field in the act of talking to itself. But the universe fiercely, almost maliciously, guards this mechanism. The cosmos does not give up its deepest secrets willingly. Creating a single Higgs boson is already a monumental statistical anomaly, an event that occurs roughly once in several billion proton collisions. It requires the most massive, sophisticated, and power-hungry machine ever engineered by human hands just to catch a fleeting glimpse of one. But creating two Higgs bosons at the exact same moment, born from the exact same spark of energy, is roughly 1,000 times rarer than that. It is an event of such staggering, punishing improbability that it sits at the very edge of what physical reality will allow us to observe. When you attempt to force this interaction, the quantum pathways actively resist. The mathematics become a tangled, frustrating web of destructive interference. Nature provides multiple quantum routes to the same outcome, and those routes actively cancel each other out, suppressing the appearance of the twin particles to a mere trickle. The universe is actively hiding its deepest secret, burying the true nature of the Higgs field behind a massive, almost impenetrable wall of subatomic noise and quantum rarity. Why subject ourselves to this madness? Why are thousands of the most brilliant minds on the planet willing to dedicate decades of their lives to sift through quadrillions of collisions, to hunt for a handful of ghostly, fleeting events buried in an ocean of background noise? Because the stakes are not merely academic, they are entirely existential. We are not just trying to add another decimal point to a textbook parameter. We are trying to determine if the physical ground we stand on is secure. The way the Higgs field interacts with itself is intimately, inextricably connected to the history and the ultimate fate of the cosmos. It holds the key to understanding how the universe cooled in the violent fraction of a second after the Big Bang, and how the fabric of space settled into the state we experience today. It is the key to understanding why there is matter in the universe instead of a cold, empty void. More profoundly, the self-interaction tells us whether this resting state of reality is permanent. Without measuring how the field behaves toward itself, we cannot know for certain if the physical laws governing our reality are absolute, or if the vacuum of space is fragile, resting precariously on a temporary ledge that could someday, without warning, simply give way. The pursuit of the double Higgs boson is the ultimate expression of human curiosity confronting the terrifying, indifferent scale of nature. We are fragile, biological creatures bound to a single rocky planet, yet we refuse to accept the superficial appearance of the world. We have confirmed the existence of the invisible foundation, but we are no longer satisfied with mere existence. We demand to know the character of the abyss. We are reaching into the absolute dark, attempting to force the cosmic architecture to reveal its hidden, self-referential rules. This is not just a story of particle physics. It is a profound, unfolding philosophical journey into the heart of what it means to exist. We are attempting to read the source code of reality, knowing full well that the answers we find buried in the data of these incredibly rare collisions may forever alter our understanding of the universe, our place within it, and the very stability of the cosmos itself. The monumental triumph of 2012 gave us the particle. But this next, terrifying chapter holds the fate of the vacuum. To truly understand the terrifying scope of the mystery hiding deep within the mathematical framework of the Standard Model, we must first confront one of the most ancient, deeply ingrained concepts in human philosophy. We must interrogate the idea of nothingness. From the time we are children, we possess a highly intuitive, biological understanding of empty space. If you were to take a sealed, heavy iron box and systematically remove every single physical object from inside of it, you would naturally assume the box is empty. If you then used advanced technology to extract every drifting molecule of atmospheric gas, pumped out every stray photon of light, and perfectly shielded the interior from the sweeping pull of outside gravity and passing cosmic radiation, you would reach what human intuition considers the absolute limit of reality. You would have created a true, perfect vacuum. It is a region of space completely devoid of substance. A dark, silent stage entirely wiped clean of all physical actors. In classical physics, this absolute emptiness was considered the default state of the cosmos. It was the blank canvas upon which the universe painted the chaotic, moving structures of matter and energy. But when we successfully stripped away the illusions of the macroscopic world and peered into the blistering, chaotic reality of quantum mechanics, this comforting notion of an empty stage completely disintegrated. We discovered that true, absolute nothingness is a physical impossibility. The universe is not a vast, empty warehouse sparsely populated by solid particles. The fundamental basis of reality is not built out of isolated objects resting in a void. Instead, reality is entirely composed of fields. You can think of these quantum fields as invisible, fluid-like mediums that stretch across the entire infinite expanse of the cosmos. They permeate everything, passing straight through the heavy core of the Earth and stretching across the freezing, unfathomable distances between the furthest galaxies. Every fundamental particle that we know of, every electron, every quark, every photon of light, is simply a localized, temporary vibration in one of these underlying, invisible fields. The fields are the true, permanent architecture of the universe. The particles are just fleeting ripples on the surface of the water. In the quantum framework, we redefine what a vacuum actually means. A vacuum is no longer an empty box. A vacuum is simply what happens when you take a patch of space and allow all the underlying fields within it to completely relax. It is the resting state of the cosmos. Take the electromagnetic field, for example. It is the brilliant, chaotic weaver of our physical world, responsible for the binding of complex chemistry, the radiant warmth of the sun, and the devastating kinetic fury of a lightning strike. When the electromagnetic field is excited, the universe is filled with light and energetic force. But if you take a region of space and you meticulously remove all the energy, the electromagnetic field simply powers down. It settles back to a baseline value of absolutely zero. It becomes completely flat, perfectly quiet, and entirely dormant. This is the behavior we expect from the fundamental forces of nature. If there is no energy to excite them, they go to sleep. Their resting state, their vacuum expectation value, is exactly zero. This brings us to the profound, reality-altering anomaly at the absolute center of our existence. The universe harbors a single, terrifying exception to this intuitive rule of cosmic silence. There is one field in the architecture of nature that absolutely refuses to sleep. The Higgs field does not turn off. If you take that heavy iron box, seal it away from the rest of the universe, and drain every single microscopic ounce of energy from the space inside, the Higgs field will not drop to zero. Even in the coldest, darkest, most isolated vacuum imaginable, the Higgs field maintains a permanent, massive, and unrelenting non-zero presence. It is a continuous, invisible background hum that never, ever fades. The Higgs field is permanently switched on everywhere in the universe at all times. It is an ocean of thick, cosmic molasses that refuses to drain away. When we say that fundamental particles acquire mass by wading through the Higgs field, they are only able to do so because this field is permanently hovering at a massive, non-zero value, actively gripping the particles as they desperately try to fly through the void. The sheer physical existence of the solid, heavy world you experience every single day relies entirely on the bizarre, seemingly unnatural refusal of the Higgs field to relax to zero. It is the unyielding floor that the entire material universe rests upon. To understand why the Higgs field behaves in this completely alien manner, and to understand how this relates to the impossible task of forcing two Higgs bosons into existence, we have to explore the invisible geometry that controls it. We must explore the concept of the cosmic landscape. In physics, systems do not simply choose how they want to behave at random. They are governed by an overarching, tyrannical rule that dictates the flow of all natural phenomena. Every physical system in the universe desperately seeks out the state of lowest possible energy. It is the reason water relentlessly flows down the side of a mountain to reach the sea. It is the reason a heavy stone resting on the edge of a cliff will inevitably fall to the valley floor. The universe is inherently lazy. It naturally gravitates toward the configuration that requires the absolute least amount of effort to maintain. For quantum fields, this invisible rulebook is known as a potential energy landscape. You can visualize this potential as a vast, theoretical topography, a mathematical terrain of rolling hills and deep valleys that dictates exactly how much energy it costs for a field to hold a certain value. The field itself acts like a heavy, perfectly smooth ball rolling across this invisible landscape. Wherever the deepest, absolute lowest point of the valley lies, that is exactly where the ball will eventually come to rest. That lowest point defines the vacuum state, the permanent resting value of the field. For almost every single field in the standard model, the geometry of this landscape is deeply intuitive and fundamentally simple. Imagine a smooth, symmetrical bowl resting on a table. The lowest point of this bowl is perfectly aligned with the exact center. If you place a ball on the sloping side of the bowl, it will immediately roll downward, losing energy until it comes to rest quietly at the absolute bottom, right in the middle. In the mathematics of the quantum realm, that exact center represents a field value of 0. Because the deepest part of the landscape is at 0, the electromagnetic field naturally settles at 0. It is an elegant, stable, and perfectly symmetric arrangement. But the mathematical landscape governing the Higgs field is a breathtaking, radical departure from this simple geometry. The Higgs potential does not look like a simple bowl. It possesses a deeply strange, deeply unstable architecture that physicists often compare to the bottom of a wine bottle or the brim of a Mexican sombrero. In the Higgs landscape, the exact center, the point where the field strength is 0, is not the bottom of the valley. In a stunning inversion of cosmic geometry, the center of the Higgs potential is actually pushed upward, forming a steep, precarious hill. The true bottom of the landscape is a deep, circular trench, a continuous, ring-shaped valley that completely surrounds the central peak. This strange topography forces the universe into a terrifying, unstable predicament. Imagine the universe in the blistering, unimaginable heat of the first fraction of a microsecond after the Big Bang. In this primordial inferno, there was so much raw, chaotic thermal energy flooding the cosmos that the Higgs field was essentially boiling. The field was violently shaking, trapped dancing on the very top of that central hill. At the absolute peak of the mountain, the field value was technically 0. In that fleeting, superheated era, the universe was perfectly symmetrical, and all the fundamental building blocks of reality were completely massless ghosts, zipping through the chaos at the speed of light. But as the universe rapidly expanded, the ambient temperature began to plummet. The blinding thermal energy cooled, and the violent shaking of the field began to subside. And this is where the bizarre geometry of the landscape demanded a catastrophic change. The field could not remain at the top of the hill. A heavy ball balancing perfectly on the razor-thin peak of a steep mountain is in a state of violent, agonizing instability. It is a highly unnatural configuration. The absolute, unyielding rule of the universe demanded that the field seek the lowest possible energy state. And so, the universe broke. The field rolled off the top of the central hill and plummeted down the steep slope, crashing into the deep, circular trough surrounding the peak. It found the lowest point in the landscape, the bottom of the valley, and it finally came to rest. But because the bottom of the valley is pushed far away from the center of the hill, this new resting place does not correspond to a field value of 0. The lowest energy state of the Higgs potential sits at a massive, permanent, non-zero value. The ball is resting at the bottom of the trough, and it requires an astronomical infusion of energy to ever push it back up the hill. This event, this microscopic, silent fall from the peak to the valley floor, is perhaps the most consequential moment in the entire history of existence. It is the exact moment the Higgs field permanently switched on. The field flooded the vacuum of space, dragging against the ghostly, weightless particles and forcing them to acquire physical mass. The ethereal, expanding flash of the Big Bang suddenly crystallized into a heavy, slow-moving reality capable of building stars, planets, and the complex biological machinery required to comprehend its own existence. You exist today entirely because the cosmic landscape possesses a hill in the center, and the field was forced to fall. This brings us to the profound, deeply hidden secret of the self-interaction, and the terrifying reason why physicists are desperate to smash 2 Higgs bosons into existence. The self-interaction of the Higgs field is not some magical, invisible tether pulling the field in different directions. The self-interaction is the landscape itself. It is the precise, mathematical curvature of the valley that the universe is currently resting in. When you strike the quantum vacuum with the massive kinetic energy of the Large Hadron Collider, you are essentially kicking that resting ball, forcing it to briefly roll slightly up the steep, invisible wall of the trough before gravity pulls it back down to the bottom. That brief, violently fast vibration up and down the side of the valley wall is what we observe as a single Higgs boson. When physicists measure the mass of a single Higgs boson, what they are actually measuring is the steepness of the valley wall right at the exact resting point. If the wall is incredibly steep, the ball vibrates very fast, and the resulting particle is very heavy. If the wall is a gentle slope, the particle is light. The triumph of 2012 proved that the ball was in the trough, and it successfully measured the immediate, local steepness of the wall it is resting against. But knowing the steepness of a single patch of dirt directly beneath your feet tells you absolutely nothing about the grand architecture of the vast surrounding valley. It tells you nothing about how the walls curve, bend, and warp as you move further away from the resting point. And this broader curvature, the sweeping shape of the valley walls, is the ultimate rulebook of the universe. This geometry dictates exactly how much energy it costs for the field to change its own value. When the field is pushed, the invisible wall of the landscape pushes back, this feedback loop. The field actively resisting its own alteration, dictated entirely by the shape of the space it rests within, is the physical definition of self-interaction. The field interacts with itself because its very presence defines the shape of the mathematical valley that confines it. A single Higgs boson, a single kick up the wall, simply does not possess the energy or the complex mechanics required to map this broader curvature. A single vibration only feels the immediate slope. To map the true geometry of the cosmic landscape, to measure how the field pushes against its own strength further up the valley wall, you have to hit the field with such terrifying, precise violence that the ball doesn't just vibrate, it fundamentally fractures the interaction. You have to kick the system so hard that the field's resistance to its own curvature forces the energy to split, birthing two distinct vibrations, two simultaneous ripples, out of the exact same initial spark. The rate at which these double ripples occur, the sheer, staggering difficulty of forcing the field to produce two particles instead of one, is directly controlled by the hidden shape of the valley walls. If the valley curves in the exact, precise mathematical arc predicted by the standard model, we will see a specific, incredibly tiny number of Higgs pairs emerge from the blinding chaos of the collider. But if the valley curves differently, if the walls bend away in strange, unpredicted angles, or if the trough is hiding deeper, darker features that our equations failed to anticipate, the number of twin bosons will change. This is why the scientific community is willing to pour decades of human life and billions of dollars into hunting a ghost inside a ghost. We are not just trying to verify a minor detail. We are trying to illuminate the dark, invisible architecture that holds reality together. We are trying to read the mathematical shape of the floor the universe sits on. For thousands of years, humanity looked up at the stars and wondered about the grand geometry of the heavens. We mapped the elliptical orbits of the planets and measured the sweeping, curved fabric of space-time governed by gravity. But the true, terrifying geometry of existence is not found in the massive, sprawling scale of the cosmos. It is found in the microscopic, invisible terrain of the quantum vacuum. We are guests living at the bottom of a highly specific, mathematical valley. The heavy, solid nature of your body, the crushing gravity of the earth beneath your feet, and the brilliant, blinding light of the stars above are all completely reliant on the exact curvature of an invisible trough we cannot see. The pursuit of the double Higgs boson is the pursuit of that hidden shape. It is a desperate, brilliant attempt to throw enough light into the quantum basement to finally see the walls of the room we are trapped in, to understand the rules of the invisible ocean that refuses to let us float away into the dark. We are fundamentally tactile creatures, bound by the evolutionary constraints of a macroscopic world. From the moment we begin to interact with our environment, our brains are hardwired to process reality as a collection of distinct, solid objects. We grasp, we hold, we measure, and we inherently trust the physical boundaries of the things we can touch. When we attempt to conceptualize the microscopic architecture of the cosmos, we naturally project this macroscopic intuition down into the quantum dark. For generations, we imagined the atom as a tiny, perfectly ordered solar system, and we pictured the fundamental particles, the electrons, the quarks, the protons, as impossibly small, perfectly round marbles. This comforting imagery serves as a cognitive shield, allowing us to mentally digest the terrifying, abstract complexity of the universe. When we hear the word particle, we instinctively picture a physical entity, a solid piece of cosmic masonry that possesses a definite edge, a permanent identity, and a quiet, enduring existence within the vast emptiness of space. But to understand the true, hidden mechanics of the Higgs field, and to grasp exactly why the greatest scientific triumph of the 21st century is profoundly incomplete, we must completely shatter this classical illusion. The universe is not a collection of tiny, solid spheres. The fundamental basement of reality is entirely fluid, and what we call a particle is merely a fleeting, ghostly illusion of permanence. Imagine an infinite, perfectly dark ocean of energy stretching across the entire expanse of the cosmos. This is the true nature of a quantum field. It is a continuous, unbroken presence that permeates every single millimeter of existence. When a machine like the Large Hadron Collider pours a staggering, violent concentration of kinetic energy into a single, microscopic point, it is not manufacturing a tiny marble out of the void. It is not assembling a physical object from spare parts. It is simply striking the surface of that invisible ocean. The sheer violence of the impact forces the field to shudder, to briefly and aggressively warp out of its resting state. That temporary, localized vibration, that momentary distortion of the underlying fabric, is what we perceive as a particle. A Higgs boson is not a physical object you could ever hope to hold in your hand or isolate in a glass jar. It is a splash. It is an intensely localized spasm in the fundamental floor of the universe. And just like a splash in a physical body of water, it is intrinsically doomed from the exact moment of its creation. The instant the Higgs boson is violently forced into existence, the immense tension of the field immediately rips it apart. It survives for an agonizingly brief fraction of a second. A lifespan so staggeringly short that the concept of time itself begins to lose all macroscopic meaning. Before this microscopic ripple can even traverse the width of a single atomic nucleus, it completely unravels. It bleeds its trapped energy back into the surrounding quantum vacuum. When the global scientific community erupted in celebration in the summer of 2012, they had not captured a solid trophy from the depths of space. They had merely recorded the fading, scattered echoes of this dying splash. They had proven that the invisible ocean could be forced to ripple, verifying its existence entirely through the violent, immediate death of its manifestation. This intensely fleeting nature of the Higgs boson is the exact reason why the widely celebrated discovery of 2012 is actually a profound dead end for understanding the deeper architecture of reality. When a single Higgs boson is born and instantly decays, it does not simply vanish into nothingness. It obeys the strict, unyielding laws of quantum conservation, transforming its localized energy into other fundamental particles. The ripple of the Higgs field violently transfers its energy into the surrounding fields of the quantum realm. It shatters into flashes of high-energy light, into heavy, unstable quarks, or into the ghost-like messenger particles of the weak nuclear force. This decay process is how we know the Higgs was ever there. We act as quantum forensic investigators, working backward from the resulting subatomic shrapnel. Over the past decade, physicists have painstakingly catalogued every possible way this single ripple can shatter. They have measured precisely how often it decays into a top quark, how often it falls apart into a bottom quark, and how frequently it produces a brilliant burst of photons. They have mapped its interactions with an astonishing level of mathematical precision. But if you step back and look closely at this incredible catalogue of scientific achievement, a glaring, terrifying pattern emerges. Every single measurement we have ever taken, every observation we have ever recorded from the collider involves the Higgs field reaching outward and touching something else. We have brilliantly mapped the external diplomacy of the field. We know exactly how it interacts with the particles of matter, and we know how it negotiates with the particles of force. We have watched it generously hand out mass to the rest of the universe. Yet, the grand, sweeping equations of the Standard Model demand something far more intimate and far more dangerous. They demand that the field must also interact with itself. Herein lies the ultimate, insurmountable roadblock. A single, solitary ripple is entirely, fundamentally blind to its own self-interaction. To understand why this limitation is absolute, we must return to the concept of the cosmic landscape, the invisible, mathematical valley where the Higgs field currently rests. When the collider strikes the quantum vacuum and creates a single Higgs boson, it is essentially giving the resting field a tiny, highly localized kick. The field vibrates slightly up the steep, invisible wall of the valley and instantly falls back down to the bottom. By measuring the mass of that single resulting particle, physicists are simply measuring the immediate steepness of the wall right at the exact resting point. It is a strictly local measurement. It tells us how tightly the field is anchored to its current microscopic spot in the universe. But the self-interaction of the field, the hidden, recursive mechanism that dictates the ultimate stability of reality, is not located at the very bottom of the valley. The self-interaction is encoded in the broader, sweeping curvature of the landscape. It is defined by how the walls of the valley bend, warp, and rise as you travel further away from the resting point. A single vibration, confined entirely to the very bottom of the trough, never explores this broader geometry. It lacks the energy, the complexity, and the mathematical scope to feel the grander architecture of the potential. When a single Higgs boson is born, it only knows its immediate surroundings, and it only knows how to decay into the foreign fields of other particles. It cannot look back at itself. It cannot push against its own extended presence because it does not possess the kinetic reach to feel the walls curving around it. The single particle is a broken mirror. It perfectly, flawlessly reflects the surrounding universe of quarks, leptons, and photons, but it possesses absolutely no capacity to cast a reflection of its own origin. We have spent over a decade staring endlessly into this shattered glass, mistakenly believing that we were looking at the complete, unvarnished foundation of reality. We thought that by understanding how the Higgs field generates the mass of the electron or the top quark, we had successfully unraveled the deepest secrets of the cosmos. We believed we had conquered the vacuum, but we were merely mapping the field's external relationships. We were watching how the foundation of reality gracefully accommodates the superficial structures built upon it. Meanwhile, the true, unguarded character of the field, the internal, self-referential rules that prevent the vacuum of space from collapsing, the mathematical laws that govern the ultimate shape and fate of the universe, remained completely hidden in the dark. They remained entirely untouched by our multi-billion-dollar machines and our decades of exhaustive, brilliant analysis. We proved that the floor of the universe exists, but we have absolutely no idea what it is actually made of or how much stress it can endure before it cracks. To truly read the hidden source code of the universe, to map the unseen walls of our cosmic prison, we must abandon the study of the solitary ripple. The era of single particle discovery has exhausted its capacity to reveal the deeper truth. We must force the field into a state of profound, unprecedented, and highly unnatural stress. If the self-interaction is the exact mathematical way the field pushes against its own presence, then the only way to observe this behavior is to create a physical situation where the field is forced to violently negotiate with itself. We must strike the quantum vacuum with an intensity so staggering and a precision so absolute that the resulting disturbance does not just vibrate locally and decay into foreign matter. We must strike it so hard that the field's resistance to its own broader curvature causes the localized energy to fracture. We must force the field to tear its own ripple in half. We need a double ripple. We must force the universe to create two Higgs bosons in the exact same infinitesimal fraction of a second, born from the exact same microscopic point of origin. This is not merely the act of producing two particles side by side. It is the act of forcing the universe to engage in a forbidden, intimate quantum conversation. When a single, massive, overwhelmingly concentrated wave of energy attempts to propagate through the Higgs field the broad curvature of the landscape, the true self-interaction of the field aggressively pushes back against it. If we can achieve the perfect, agonizingly rare collision, that invisible resistance will cause the wave to spontaneously bifurcate. Two distinct Higgs bosons will emerge, born not from the collision of external matter, but born entirely from the field tearing itself apart under the immense, crushing stress of its own geometry. By capturing the scattered, decaying shrapnel of these twin ripples, by measuring the exact angle, the precise momentum, and the shared energy with which they fly apart before they vanish, we can finally begin to reverse engineer the shape of the invisible walls that force them to split. We can trace the mathematical arc of their divergence back to the curvature of the cosmic landscape. We are no longer simply trying to weigh a particle. We are attempting to blindly trace the exact mathematical contours of the space that existence itself occupies. The twin Higgs bosons are the only physical mechanism in the entire cosmos capable of carrying this profound geometric information from the quantum dark out into the light of human awareness. They are the twin keys to the ultimate, final lock of the Standard Model. The single particle gave us the comforting, gentle illusion of a finished puzzle. It allowed us to sleep soundly, believing the floor beneath our feet was solid, simple, and perfectly, mathematically understood. We celebrated the single ripple because it told us exactly what we wanted to hear, that we were right, and that the universe made sense. But the mathematical demand for the double ripple shatters that comfort. It serves as a cold, terrifying reminder that the universe does not owe us simplicity, and it certainly does not owe us closure. The cosmos operates on layers of recursive, deeply hidden logic that actively resist our observation. To demand two Higgs bosons is to demand that reality drop its final, most fiercely protected veil. It is a profound, humbling realization that our journey into the microscopic abyss has barely even begun. The true, terrifying character of the cosmic foundation is not etched into the solid face of a tiny marble. It is waiting to be written in the chaotic, vanishing, and nearly impossible ink of a double ripple. There is a pervasive, deeply embedded misconception about how humanity actually investigates the fundamental building blocks of the universe. When we hear about sprawling, multi-billion-dollar facilities like the Large Hadron Collider, we instinctively rely on the vocabulary of the Industrial Revolution. We imagine these colossal rings of superconducting magnets as highly advanced, microscopic assembly lines. We picture scientists standing at control panels, pulling levers, and methodically manufacturing specific subatomic particles on demand, stamping them out one by one like coins dropping from a mint. This industrial metaphor provides a comforting illusion of control. It suggests that humanity has successfully tamed the quantum realm, that we can simply bend the underlying fabric of reality to our will and force it to produce whatever fundamental ingredients we desire. But the reality of experimental particle physics is infinitely more chaotic and far more violent than any factory floor. We are not builders in the quantum basement. We are instigators. The Large Hadron Collider does not manufacture anything. It is an arena of pure, focused destruction. We take microscopic packets of protons, accelerate them through a freezing, absolute vacuum until they are traveling at just a tiny fraction of a percent shy of the absolute speed limit of the universe, and we force them to cross paths. We are taking an astronomical amount of kinetic energy, and relentlessly squeezing it down into a localized point in space-time that is millions of times smaller than a single grain of sand. We are not assembling particles. We are intentionally sparking a localized, subatomic cataclysm. We are violently striking the quantum vacuum, hoping that the sheer, blinding trauma of the impact will force the invisible fields of the universe to momentarily reveal their hidden architecture. And it is within this chaotic, roaring environment of forced subatomic trauma that physicists are hunting for the ultimate prize. They are attempting to trigger an event of such staggering, punishing improbability that it defies the very limits of experimental science. They are hunting for Higgs Pair Production. To understand exactly what this means, we must first aggressively dismantle the most common misunderstanding surrounding this experiment. When you hear the phrase that physicists are trying to make two Higgs bosons at once, it is remarkably easy to conjure the wrong mental image. Inside the collider, protons do not travel single file. They are bundled together in dense, needle-like clouds, and when two of these clouds cross inside the heart of a detector, dozens of individual proton collisions can happen almost simultaneously, scattered across the same microscopic intersection. Now, imagine that in one of those chaotic collisions, a single Higgs boson is violently brought into existence. And then, a tiny fraction of a millimeter away, in a completely separate collision happening between two different protons at almost the exact same microsecond, a second, solitary Higgs boson is born. You would technically have two Higgs bosons existing inside your detector at the same time. But this scenario is entirely useless to the physicists at CERN. It is a mere statistical accident. It is a coincidence of timing that teaches us absolutely nothing new about the fundamental laws of nature. Those two particles share no origin. They share no quantum history. They were born from different sparks, emerging from different pockets of localized energy. They are two separate, solitary ripples on the cosmic pond, entirely blind to one another and entirely blind to the deeper curvature of the field they emerged from. The genuine phenomenon, the elusive double ripple that holds the key to the foundation of reality, is fundamentally different. Higgs pair production is not two collisions happening side by side. It is the emergence of two Higgs bosons out of one single, unified quantum event. We are looking for a singular moment in space-time where two protons collide, their internal constituents fuse, and an immense, localized concentration of energy pools into the vacuum. And from that single, microscopic inferno, two Higgs bosons must emerge together, born from the exact same violent spark, sharing the exact same quantum origin. This is not a coincidence of timing. This is a profound, intimate quantum conversation. It is a single strike on the invisible surface of the field that is so perfectly tuned and so unimaginably intense that the field fractures the energy and brings forth twins. The distinction between these two scenarios is the entire crux of the experiment, and grasping the sheer rarity of this unified event requires a radical readjustment of our understanding of scale. The universe is heavily, actively biased against giving up its secrets, and the Higgs field is notoriously difficult to interact with. When protons shatter against each other hundreds of millions of times every single second inside the collider, the vast, overwhelming majority of that wreckage is composed of ordinary, highly understood subatomic debris. The particles that actually make up a proton, the light up and down quarks, and the massless gluons holding them together, barely interact with the Higgs field at all. They slip through the cosmic molasses almost entirely unnoticed. Therefore, to summon even a single Higgs boson, the collision cannot rely on a direct impact. It has to proceed through an incredibly rare, highly complex quantum loophole. The immense kinetic energy of the crash must spontaneously summon a loop of the heaviest particles nature provides, usually a fleeting triangle of top quarks, which then act as a heavy, temporary bridge to finally grip the Higgs field and force it to ripple. Because this necessary chain of events is so highly indirect, a single Higgs boson is an absolute ghost. It surfaces roughly once in several billion collisions. Finding a solitary Higgs is already the equivalent of searching for a single, specific needle hidden inside a mountain of ordinary steel pins. Now, take that staggering, mind-bending rarity and demand that the universe do something infinitely harder. Demand that the same collision produce not one, but two ripples from the same spark. The improbability of this event does not merely add up, it compounds with devastating mathematical severity. To produce a genuine Higgs pair, the universe has to meet an entirely new set of impossibly strict conditions. The initial collision must contain a drastically higher threshold of localized energy, and the field must engage in a behavior that it is mathematically predetermined to avoid. Because of the destructive quantum interference that governs these pathways, the fundamental laws of probability actively work to suppress the double ripple, driving the rate of its occurrence deep into the subatomic floor. The result is a phenomenon that is roughly 1,000 times rarer than a single Higgs boson. Let that number settle into your mind. If finding one Higgs boson is finding a needle in a massive haystack, finding a genuine pair is searching for a needle hidden inside 1,000 of those haystacks stacked together. For every 1,000 incredibly rare, highly celebrated collisions that manage to successfully summon a single ripple, only one will possess the perfect, astronomical alignment of quantum variables to summon a pair. Out of the quadrillions upon quadrillions of violent impacts orchestrated beneath the surface of the Earth over years of continuous operation, physicists are searching for an event so scarce that the total number of clean, identifiable candidates can be counted on a human scale. It is a rarity that borders on physical impossibility. So, what actually happens in that 1 in a trillion instant? What is the precise, microscopic reality of the double ripple when the universe finally relents and allows it to happen? When the perfect collision occurs, the staggering kinetic energy of the smashing protons does not simply bleed out into a chaotic spray of ordinary matter. The energy is hyper-concentrated, pooling violently into the deepest layers of the quantum vacuum. Through that rare, heavy loop of intermediary particles, this raw energy violently grips the Higgs field, but it grips it with far too much intensity. The localized trauma to the field is so severe that it summons an anomaly. It brings forth what physicists call a virtual Higgs boson. A virtual particle is not a real, physical object that you could ever measure, even in principle. It is a mathematical ghost, a temporary fluctuation permitted only by the bizarre leniency of Heisenberg's uncertainty principle. The universe allows this virtual phantom to borrow an astronomical, completely unstable amount of energy from the vacuum, provided that it repays that energy debt in an infinitesimally brief fraction of a second. This virtual Higgs is a massive, over-energized distortion in the cosmic landscape. It is thrashing violently, saturated with far more kinetic fury than a standard ripple can possibly contain. And it is in this exact, fleeting microsecond of extreme instability that the deepest secret of the universe takes hold. The virtual Higgs is sitting on the invisible slope of the cosmic valley, the mathematical landscape that defines the vacuum of space. Because the field interacts with itself, because the walls of that valley are curved in a highly specific, unyielding geometry, the virtual ripple cannot simply dissipate. The broad curvature of the field aggressively pushes back against this massive concentration of energy. The invisible architecture of the universe itself applies a crushing, highly localized stress to the anomaly. Under the immense weight of this self-interaction, the virtual phantom cannot hold its structure. The energy is forced to seek a more stable configuration. The underlying tension of the field violently fractures the anomaly, tearing the single, over-energized distortion completely in half. In a blinding flash of subatomic alchemy, the energy is perfectly divided. The virtual ghost vanishes, its energy debt immediately settled, and in its place, two real, distinct Higgs bosons are violently thrust into existence. They fly apart from the exact same microscopic point of origin, carrying the shared energy, the exact momentum, and the indelible mathematical fingerprint of the invisible landscape that forced them to split. This entire, breathtaking sequence, the violent collision, the pooling of the energy, the summoning of the virtual phantom, the crushing resistance of the field's curvature, and the final, explosive bifurcation into two distinct ripples, transpires in a window of time so unimaginably brief that light itself can barely cross the width of a single atom. By the time the detectors surrounding the collision point register any activity whatsoever, the twin Higgs bosons have already decayed. They have already vanished back into the dark, transforming into lighter, more stable particles that spray outward through the layers of the machine. The event is over before the macroscopic world can even blink. When you truly grasp the mechanics of this incredibly violent, highly specific chain of events, you realize that the language of manufacturing is entirely obsolete. The physicists at CERN are not building a machine on a sterile assembly line. They are not stamping out twin particles from a cosmic press. They are capturing lightning in a bottle. They have constructed the largest, most sophisticated meteorological instrument in human history, solely to study a storm that rages in the absolute microscopic dark. They are orchestrating trillions of localized subatomic hurricanes, purposefully creating an environment of maximum, controlled chaos, and then waiting, with agonizing patience, for a very specific, ultra-rare double flash of quantum lightning to strike. It is an endeavor that requires us to essentially bully the universe into revealing its deepest, most protected mechanisms. We are taking the very foundation of reality, the invisible floor that holds the entire cosmos together, and we are subjecting it to an extreme, unnatural stress test. We want to see exactly how much energy the fabric of space can absorb before the mathematical rules governing its own existence force it to fracture. There is a profound, almost terrifying beauty in this mechanic. We are not observing the universe in its natural, quiet state. We are actively provoking it. The double ripple is not an object that exists peacefully in the wild. It is a highly constrained, violently forced reaction. It only occurs when the raw, untamed energy of our technological ambition directly collides with the unyielding, invisible curvature of the cosmic landscape. This rare, violent mechanism forces us to reevaluate our relationship with the physical world. We spend our lives moving through a macroscopic environment that feels stable, solid, and completely indifferent to our presence. We assume the rules of nature are simply passive laws written in the background, but the mechanics of the twin Higgs reveal a universe that is highly reactive, a foundation of reality that possesses its own internal, geometric tension. The field is not just a passive medium, it is an active, resisting architecture. To capture this double ripple is to read the invisible stress fractures in the walls of reality. It is to observe the exact, mathematical moment where the universe is forced to negotiate with its own existence. We are fragile, biological observers, utilizing the most extreme violence we can technologically harness just to provoke a whisper from the absolute dark. We are chasing the ghost of a ghost, knowing that within that fleeting, fractured ripple lies the ultimate geometric truth of the space we inhabit. Human beings possess a deep, almost desperate psychological need for linear narratives. We are a species that evolved to interpret the world through the comforting framework of direct cause and effect. When we look at a path winding through an ancient forest, or trace the delicate fractures spreading across a sheet of failing ice, our brains instinctively assume an unbroken, singular chain of events. We believe that if an event occurs in the physical world, it must have arrived there by traveling along one specific, identifiable route. This intellectual linearity is the absolute foundation of our macroscopic logic. It is the rulebook that allows us to hunt, to build, and to safely navigate the predictable mechanics of our daily lives. If a window shatters, we look for the single stone that was thrown. If a fire ignites, we look for the specific spark that started the reaction. We inherently believe that reality is honest, transparent, and completely free of duplicity. But when we step across the threshold of the subatomic realm and descend into the blistering, chaotic depths of particle physics, this comforting linearity is entirely stripped away. We discover that nature, at its most fundamental level, does not operate through straight lines or singular paths. Instead, the quantum basement of the universe is a place governed by a hallucinatory web of simultaneous possibilities. It is an alien landscape where an event can happen in multiple different ways at the exact same time, and where those separate, invisible histories can actively collide, fuse, and fight one another in the dark. To understand why the pursuit of the double Higgs boson is one of the most frustrating and agonizing endeavors in the history of science, we must confront the ultimate illusion of the subatomic world. We must explore the maddening architecture of nature's smoke and mirrors. When physicists force packets of protons to smash together inside the colossal, freezing ring of the Large Hadron Collider, they are trying to provoke the Higgs field into raising two simultaneous ripples out of a single violent spark. We understand this conceptually as a grand geometric goal, an attempt to map the hidden valley of the cosmic landscape and measure how the field interacts with its own presence. If the universe were a simple, classical machine, the mechanics of this experiment would be beautifully direct. We would trigger the collision, the raw energy would pool into the vacuum, and that concentration of power would invoke the field's self-interaction, forcing a single virtual disturbance to split cleanly into two real, measurable particles. We could simply count the resulting pairs, measure their angles, and immediately read the source code of reality. But the quantum universe refuses to be so accommodating. The fabric of reality carries a profound complication that actively sabotages our attempt to see the truth. The universe does not possess just one single way to create a pair of Higgs bosons. It has multiple, completely different quantum pathways that can lead to the exact same final destination. Imagine walking into a sealed, silent room and finding two pristine drops of water resting side by side on a glass table. In the macroscopic world, you could reasonably assume they arrived there through a simple, singular process, perhaps a localized condensation or a deliberate drop from a pipette. But inside the proton collision, when two real Higgs bosons suddenly emerge from the blinding subatomic wreckage, they do not carry a label detailing their history. They do not possess a genetic code that reveals how they were made. When they fly outward through the layers of the detector, they appear absolutely identical, regardless of the path the universe took to forge them. And this is where the scientific nightmare truly begins. Out of the multiple distinct routes that the universe can exploit to produce a Higgs pair, only one single pathway actually involves the self-interaction we are desperate to measure. Let us trace this primary, coveted pathway through the quantum dark. The immense kinetic energy of the smashing protons shatters their internal structure, creating a localized, superheated inferno. Through a rare and complex loop of heavy top quarks, this energy violently grips the Higgs field, exciting it so severely that it summons a virtual Higgs boson into existence. This virtual entity is an unstable, over-energized spasm in the fabric of space, because it is sitting on the curved, invisible wall of the cosmic landscape. It experiences the field's internal resistance. The field pushes back against its own strength. Under the immense, localized pressure of this self-interaction, the virtual phantom fractures, tearing its own ripple cleanly in half and birthing two real, stable Higgs bosons that fly out into the world. This is the pure signal. This is the pathway that carries the definitive fingerprint of the landscape's shape. It is the exact mathematical truth that thousands of physicists are risking their careers to find. But simultaneously, completely independently, the universe is also exploiting an entirely different, alternative route to produce the exact same result. In this secondary pathway, the initial energy of the proton collision also creates a frantic loop of heavy quarks. But instead of exciting the Higgs field into a single virtual disturbance that splits through self-interaction, this quark loop behaves in a far more direct, aggressive manner. The heavy particles inside the loop directly radiate two separate Higgs bosons into space, casting them out into the vacuum like twin flashes of subatomic light. The final outcome of this secondary route is exactly the same. Two real Higgs bosons fly outward into the detector. But this pathway completely, utterly bypasses the self-coupling of the field. The two ripples were born together from the same quark loop, but they never spoke to each other. They never felt the internal resistance of the cosmic landscape. They never invoked the field's self-interaction. If you could somehow isolate this secondary route and study it alone for 1,000 years, it would tell you absolutely nothing about the shape of the valley the universe lives in. It is an imposter. It is a brilliant, subatomic counterfeit that yields the exact same physical evidence while completely hiding the truth we are searching for. If these two separate pathways simply occurred side by side in the collider like two independent assembly lines, the situation would be challenging but entirely manageable. Scientists could use advanced statistics to model the counterfeit route, calculate exactly how many pairs it should produce on average, and simply subtract that number from the total count, leaving behind the pure signal of the self-interaction. This is the logical, additive methodology of the macroscopic world. If you have two separate pipelines feeding water into a single reservoir, the total volume of water is simply the first pipeline plus the second pipeline. They do not interfere with one another. They quietly coexist. But in the strange, deeply unsettling realm of quantum mechanics, probabilities do not add together. Amplitudes do. And when multiple pathways lead to the exact same indistinguishable final state, the universe enters a condition of absolute, overlapping duplicity. The separate histories do not remain independent. They overlay on top of one another within the quantum vacuum, and they trigger the ultimate nightmare of modern physics, quantum interference. To grasp the sheer, frustrating horror of this phenomenon, we must abandon the concept of particles entirely and remember that these pathways are governed by the mathematics of waves. Each potential history is assigned a quantum amplitude, a wave-like value that possesses a specific height, a specific frequency, and a specific alignment in space. When the collision occurs, the wave of the self-interaction pathway and the wave of the counterfeit direct radiation pathway are summoned simultaneously into the exact same microscopic point of space-time. They do not pass through each other like ghosts. They crash into one another in a violent, invisible collision of phases. And by a cruel, seemingly malicious trick of cosmic mathematics, these two primary waves possess opposite alignments. Where the wave of the self-interaction pathway rises into a crest, the wave of the direct radiation pathway plunges into a deep, matching trough. When these two conflicting histories meet in the quantum void, they do not reinforce one another. They actively fight. They lock together in a state of fierce, destructive interference, meticulously and violently tearing each other down. The crest of the pure signal is aggressively dragged into the trough of the counterfeit route. They partially erase one another from the fabric of reality, silencing the quantum vibration before it can ever manifest as a real particle that our detectors can see. This destructive clash is the true, hidden reason why Higgs pairs are so devastatingly, impossibly rare inside the Large Hadron Collider. It is not merely that the universe is reluctant to excite the field, or that the energy threshold is difficult to achieve. The scarcity is a direct consequence of this internal subatomic war. The two main pathways are acting like noise-cancelling headphones for the foundation of reality, utilizing their opposite quantum phases to actively mute the very whisper we are trying to hear. The signal is being choked to death by its own alternative history. Nature has constructed a perfect system of smoke and mirrors, a mathematical cloaking device that uses the laws of probability to hide the source code of existence right at the exact moment we attempt to measure it. The consequence of this destructive interference is a mathematical trap that shatters the very concept of a straightforward measurement, because the two pathways are continuously fighting and cancelling each other out. the total rate at which Higgs pairs are produced, does not respond to the self-interaction strength in a simple, straight-line way. Imagine that you are standing at a cosmic control panel and you grab the dial that controls the strength of the Higgs self-interaction. If you were to turn that dial up or down, your macroscopic intuition would predict that the number of Higgs pairs detected inside the collider would rise or fall proportionally. If you increase the self-interaction, the signal should get stronger, and the number of pairs should go up. If you decrease it, the pairs should go down. But because of the destructive interference, turning the dial completely distorts the balance of the subatomic fight. If you were to start at the predicted value of the standard model and begin to alter the self-interaction, making it slightly different than our equations expect, you would initially make the cancellation even more perfect. The two waves would align even more flawlessly in their opposition, driving the total number of detected Higgs pairs down to an absolute, agonizing minimum. The signal would nearly vanish into total silence. But if you continue to turn the dial further in that same direction, making the self-interaction wildly, radicals different than anyone ever anticipated, the balance shifts entirely. The wave of the self-interaction pathway grows so massive and so intense that it completely overwhelms the counterfeit route. The cancellation fails, the smoke and mirrors shatter, and the total rate of Higgs pair production suddenly begins to rapidly, violently climb back up like a rocket. This non-linear relationship creates a terrifying geometric topography in our data. It forms a deep, symmetrical valley, a mathematical parabola. And this valley introduces a state of frustrating, absolute ambiguity that haunts the dreams of experimental physicists. Suppose the colossal supercomputers at CERN sift through quadrillions of collisions over years of continuous operation, battle through the deafening background noise, and finally manage to isolate a specific, tiny handful of genuine Higgs pairs. They count the events, perform the exhaustive statistical analysis, and arrive at a definitive, hard number for the total rate of production. They have found a solid fact. But when they hold that number up against the mathematical valley of the Higgs potential, they discover that a single, specific rate of production maps perfectly to two completely different locations on opposite sides of the valley. The graph has two identical heights. The single count points directly to two entirely separate, irreconcilable realities. One side of the valley tells us that the Higgs field is perfectly normal, interacting with itself with the exact, elegant strength predicted by the standard model. It confirms that the universe is stable, compliant, and precisely as we imagined it. But the exact same number of detected particles also maps perfectly to the opposite side of the valley. This darker, alternative reality claims that the Higgs field is fundamentally broken, interacting with itself with wild, unpredicted, and radical strength, masked entirely from our sight by the accidental, perfect efficiency of the quantum cancellation. This is the ultimate tyranny of the subatomic realm. Nature does not merely hide its secrets behind the vast distances of the cosmos or the microscopic scale of the atom. It actively cloaks them in fundamental ambiguity. It hands us a physical measurement where the answer is double-faced. We are left holding a riddle with two distinct, perfectly valid solutions, both completely capable of explaining the physical reality we observe, and our instruments, on their own, have absolutely no capacity to tell us which side of the valley we are actually standing on. It is an experimental dead end that forces us to confront the profound limits of our own scientific methodology. This maddening ambiguity forces a deep, almost existential reflection on the relationship between human consciousness and the universe we are attempting to decode. We look out at the cosmos, and we assume that information is clean, that facts are absolute, and that reality wants to be understood. We construct massive machines of steel and silicon, pouring the collective intellect of our species into the dark, believing that if we just look closely enough, the universe will eventually drop its veil and hand us a single, unvarnished truth. but the mechanics of subatomic interference suggest a far more mysterious and deeply tattered framework. It reveals a reality that is fundamentally masked by its own nature. The deeper we journey into the quantum dark, the more the clear boundaries of information begin to blur. We find ourselves trapped in a cosmic hall of mirrors, where every signal we capture is distorted by alternative histories that never technically happened, yet possess the power to violently erase the history that did. We are forced to accept that the ultimate foundation of the material world may not be a simple, solid fact that can be neatly filed away in a textbook. Reality, at its core, appears to be a continuous, silent argument, a state of perpetual tension where different pathways, different forces, and different potential universes are constantly fighting to a standstill in the void. The solidity of the ground beneath your feet, the mass of your body, and the predictable flow of macroscopic time are not the baseline of existence. They are the temporary, fragile truce born from a subatomic war that refuses to ever settle on a single, clear answer. We are conscious observers attempting to read a message that nature has explicitly written in double-sided ink, left to wander the valley of ambiguity, forever searching for a way to break the mirror and see the true face of the cosmos hiding behind the cancellation. We navigate our lives completely dependent on the reliability of human vision. We believe, with an absolute and instinctual conviction, that to truly understand a physical phenomenon, we must be able to observe it directly. When we want to understand the violent birth of stars or the sprawling architecture of ancient galaxies, we build colossal mirrors, polish them to a flawless sheen, and launch them into the freezing, silent void of space to capture the ancient light. We trust the image. We trust the direct evidence of our senses, extended by the reach of our technology. But as we leave the macroscopic universe behind and descend into the subterranean tunnels beneath the Alps, this fundamental reliance on direct observation completely and irreversibly collapses. The Large Hadron Collider is arguably the most complex sensory organ our species has ever engineered, yet it is fundamentally, inherently blind to the very phenomenon it was built to find. A Higgs boson does not live long enough to be seen. Its existence is an incredibly violent, localized shudder in the invisible fabric of reality, a temporary ripple that the universe immediately, aggressively corrects. It persists for a fraction of a second, so incomprehensibly brief that the very concept of time begins to lose all macroscopic meaning. Before this microscopic distortion can travel even the width of a single atomic nucleus, it violently unravels. It bleeds its trapped energy back into the surrounding quantum fields. When the universe is finally forced into the extreme, agonizingly rare configuration required to produce two Higgs bosons from a single, unified spark, the twin ripples vanish almost simultaneously. We never see the pair. We will never possess an instrument fast enough, or a sensor delicate enough, to catch them in the act of existing. The universe deletes the original document the exact moment it is written. All that remains is the subatomic shrapnel. As the twin ripples collapse, their massive, concentrated energy cascades downward, birthing a sudden, frantic spray of lighter, more stable particles that fly outward from the collision point. We are left entirely with the wreckage. In this dark, subterranean environment, the endeavor of particle physics ceases to be an act of observation. It becomes an act of post-mortem forensic reconstruction, executed on a scale that defies human imagination. If this microscopic crime scene existed in a quiet, isolated vacuum, the forensic reconstruction might be a straightforward, manageable task. But the interior of a high-energy proton collision is the exact opposite of quiet. It is an environment of deafening, blinding, and absolute kinetic chaos. Protons are not neat, solid, indivisible spheres. They are violent, boiling bags of quarks and gluons, bound together by terrifying internal tensions. When two of these bundles are forced to cross paths at nearly the speed of light, they do not simply bounce off one another, they shatter. They explode into a screaming, chaotic torrent of subatomic debris. For every single, miraculous collision that manages to perfectly strike the quantum vacuum and summon the elusive twin Higgs, there are billions upon billions of ordinary, mundane impacts. These everyday collisions produce an overwhelming, roaring ocean of perfectly normal particles. They flood the detectors with a blinding blizzard of overlapping tracks, massive energy deposits, and radiating kinetic fury. This introduces the most agonizing, maddening reality of the entire experiment. The particles that the Higgs boson decays into. The specific heavy quarks, the sudden flashes of high-energy light, are not uniquely exotic. They are the exact same species of particles that are violently thrown out by the billions in the ordinary background noise of the collider. The mundane, uninteresting physics of the standard model perfectly, flawlessly mimics the exact same decay signature as the ultimate prize we are desperately hunting for. You are not looking for a needle in a haystack. A needle is forged from cold steel, and a haystack is made of dried grass. They are fundamentally different materials, easily separated if you search long enough. Inside the dark heart of the Large Hadron Collider, you are searching for a needle hidden inside a towering mountain of identical needles. The universe is actively dressing the mundane background noise in the exact same clothing as the profound, existential signal. How does the human mind ever begin to unravel a forgery of this magnitude? The immense detectors, towering, cathedral-sized structures of heavy steel, highly refined silicon, and superconducting wire are built in concentric layers around the collision point, resembling the rings of a massive, technological onion. When the chaotic spray of debris flies outward from the impact, it passes through these layers, leaving behind an intricate, overlapping web of electronic breadcrumbs. The innermost layers of the machine, bathed in a terrifyingly intense magnetic field, are designed to track the precise trajectory of charged particles. The invisible magnetic force forces the flying particles to curve, and by measuring the exact mathematical arc of that curve, physicists can precisely calculate their momentum. Further out, massive, dense layers of specialized crystalline materials act as absolute kinetic walls. They entirely absorb the flying particles, bringing them to a violent halt, and precisely measure the raw energy they carried outward into the dark. With this scattered, highly fragmented web of electronic footprints, the colossal supercomputers at CERN must work backward through the flow of time. They take two seemingly random particles from the chaotic, overlapping spray of debris and ask a profound mathematical question. If we assume, for a moment, that these two specific pieces of shrapnel came from the exact same vanished parent, and we mathematically combine their trajectories, their angles, and their absorbed energy, what was the exact mass of the ghost that birthed them? If that calculated phantom mass perfectly matches the known, highly specific weight of a single Higgs boson, the supercomputer registers a potential candidate. But for this terrifying experiment, that is only half of the battle. You are hunting for twins. You must dive back into the exact same chaotic spray of subatomic debris, sort through the remaining tracks, find two entirely different particles, and perform the exact same mathematical resurrection. Only if both reconstructed parents perfectly match the mass of the Higgs boson do you have a single, isolated sighting of the double ripple. The combinatorial chaos of this process is staggering. If the computer pairs the wrong particles together, if it takes a piece of shrapnel from the first vanished Higgs and accidentally pairs it with a piece from the second, or far worse, pairs it with a piece of entirely unrelated background noise, the mathematical reconstruction computes absolute nonsense. The phantom mass completely misses the target. The supercomputers must relentlessly test every possible combination, filtering out millions of false, dead-end paths for every single collision that occurs inside the machine. And yet, even when the silicon minds successfully navigate the maze, even when they perfectly reconstruct two phantom masses that flawlessly point to a twin Higgs event, the physicists can never, under any circumstances, trust it. You can never look at a single candidate event, no matter how perfect the mathematics appear, and declare victory. Because the background ocean of ordinary collisions is so incredibly vast. The mundane physics of the universe will occasionally, by pure, blind statistical luck, throw out four ordinary particles that happen to perfectly mimic the exact geometry and energy distribution of a twin Higgs decay. A single event is entirely, fundamentally ambiguous. It could be the profound architectural truth of the cosmos, revealing the hidden shape of the cosmic landscape, or it could be an absolutely meaningless statistical accident. This agonizing, inescapable ambiguity is the exact reason why the Large Hadron Collider cannot simply run for a few weeks, capture a handful of images, and shut down. It is the reason why humanity must keep the massive superconducting ring brutally cold and operational for years on end. It is the reason why we must orchestrate quadrillions upon quadrillions of microscopic collisions, generating datasets so incomprehensibly massive that they strain the limits of the global computing infrastructure, requiring vast networks of servers distributed across the entire planet just to store the resulting numbers. We are not simply trying to find the signal in the dark. We are engaged in a brutal, unrelenting war of attrition against the background noise of the universe itself. The background is not a smooth, predictable, flat floor of data. It breathes. It fluctuates. The inherently random, probabilistic nature of quantum mechanics means that the number of lookalike imposters will naturally rise and fall over time in entirely unpredictable ways. In a small dataset, a random, localized upward swing in the background noise can look exactly like the profound, rising signal of a twin Higgs event. A statistical anomaly can perfectly disguise itself as a breakthrough. To definitively prove that the signal is real, you must completely drown the background in raw statistics. You must collect so much data over such a vast expanse of time that the random, unpredictable fluctuations of the background eventually smooth themselves out, leaving only the cold, hard, unyielding average of ordinary physics. Only then, against that perfectly mapped, perfectly understood horizon of mundane chaos, can the genuine, underlying signal of the twin Higgs slowly begin to reveal itself. It must rise not as a handful of lucky, isolated events, but as a towering, undeniable statistical mountain. The researchers are looking for a sheer excess of specific data points that is so incredibly pronounced and so perfectly aligned with the theoretical predictions that the laws of probability flatly refuse to explain it away as a coincidence. You cannot politely ask the universe to reveal its underlying structure. You have to bludgeon the void with sheer, staggering volume until the truth is mathematically forced to emerge from the noise. This grueling, forensic nightmare forces us to confront a deeply humbling reality about our relationship with the cosmos. We naturally want the universe to be a clear, transparent window. We want reality to be a pristine environment where the fundamental truths of existence are proudly displayed, waiting patiently for our conscious minds to discover them. We want the source code of reality to be highly readable. But the quantum vacuum is not a quiet library of information. It is a battlefield. Information is not freely given. It is aggressively, meticulously hidden behind an impenetrable wall of kinetic chaos, rapid subatomic decay, and perfect, statistical mimicry. The universe actively conspires to keep its deepest mechanisms shrouded in a deafening roar of ordinary, uninteresting events. The fact that we can decipher this subatomic storm at all is a profound reflection of our species. The realization that fragile, biological creatures bound to the surface of a single rocky planet can build sprawling, subterranean machines capable of tracing the vanishing, invisible footprints of a double ripple through an infinite ocean of noise is a breathtaking testament to the sheer, unyielding force of human reason. We are attempting to read a message written in vanishing ink, lost in a sprawling archive of flawlessly forged documents. And yet, slowly, against all astronomical odds, and fighting through the absolute limits of probability, we are forcing the dark to speak. We spend so much time looking downward into the microscopic, subterranean depths of our particle accelerators that we risk losing sight of the grander canvas. When we obsess over the elusive mechanisms of quantum interference, or the maddening forensic nightmare of sorting through subatomic debris, it is remarkably easy to view the search for the double ripple as a purely academic puzzle. We begin to think of it merely as an attempt to fill an empty, highly specific cell in a massive spreadsheet of physical parameters. But the reason thousands of the most brilliant minds on the planet are willing to dedicate their entire lives to hunting the ghost of a ghost is not simply to satisfy an esoteric mathematical curiosity. To understand the true stakes of this endeavor, we must radically shift our perspective. We must leave the cold, quiet tunnels beneath the Alps and travel backward across the staggering, unimaginable expanse of cosmic time. We have to rewind the clock roughly 13.8 billion years, moving past the formation of the Earth, past the violent ignition of the very first ancient stars, and plunge directly into the blinding, incomprehensible inferno of the early universe. In the very first fractions of a single microsecond after the cosmos was born, reality did not resemble the cold, highly structured, and heavily populated void we inhabit today. The newborn universe was a confined, perfectly dense crucible of unimaginable heat. It was a space so completely saturated with raw, violently churning thermal energy that the physical laws we take for granted simply could not function as they do now. In this primordial furnace, the architecture of nature was entirely fluid, and the Higgs field, the invisible cosmic ocean that currently gives mass to the universe, was experiencing a radically different reality. We know that in our current, freezing universe, the Higgs field rests in a deep valley, a mathematical trough that forces it to maintain a permanent, heavy presence. But temperature fundamentally alters the shape of this invisible cosmic landscape. If you pump enough raw thermal energy into the fabric of space, the mathematical geometry actually changes. In the blinding heat of the Big Bang, the steep central hill of the Higgs potential melted entirely away. The deep, circular valley that currently traps the field was completely erased. The topography of the vacuum flattened out into a simple, smooth, symmetrical bowl. In that blistering, superheated era, the absolute lowest energy state for the Higgs field was right in the middle, resting precisely at zero. The field was completely, fundamentally dormant, because the field was asleep. The mechanism of mass did not exist. The fundamental building blocks of reality, the ancient ancestors of the heavy electrons and quarks that now actively construct your body and your brain, were completely weightless. They were ethereal ghosts, entirely unrestrained by the physics of mass. They moved through the blinding thermal chaos of the early universe at the absolute maximum speed limit of existence, the speed of light. Because they were traveling at the speed of light, they could not slow down, they could not orbit one another, and they could not bind together. They could not form the heavy atomic nuclei of the elements. There was no chemistry, no complex geometry, and no possibility of solid structure. The universe was a featureless, perfectly symmetrical ocean of pure, rushing energy. It was beautiful in its absolute mathematical perfection, but it was completely incapable of harboring complexity or life. But this state of flawless, superheated symmetry was not destined to endure. Driven by the relentless mechanics of the Big Bang, the early universe rapidly expanded, pushing the boundaries of space-time outward and causing the suffocating concentration of thermal energy to rapidly diffuse. The cosmos began to violently cool, and as the temperature plummeted across the expanding void, the invisible mathematical landscape governing the Higgs field began to warp and shift. The flat, featureless plain began to buckle under the strain of the cooling vacuum. A steep, precarious hill rose in the exact center of the potential, and a deep trough rapidly carved itself into the surrounding mathematical space. The resting point of zero was suddenly no longer the lowest state of energy. The Higgs field found itself balancing precariously on the razor-sharp peak of a newly formed mountain, trapped in a state of terrifying, unsustainable instability. And then the universe broke. In an event of staggering cosmic consequence, the Higgs field rolled off that central peak and crashed down into the newly formed valley. It flooded the vacuum of space, permanently switching on across the entire infinite expanse of reality. Physicists call this monumental event electroweak symmetry breaking. It was the exact moment the cosmos crystallized. As the field suddenly flooded the void, the frantically racing, weightless particles abruptly slammed into the invisible cosmic molasses. They were violently decelerated, forced to drag against the newly awakened field, and in that blinding instant, they acquired physical mass. The universe slowed down. The perfect, featureless symmetry of the early cosmos was permanently shattered, replaced by a heavy, clunky, and beautifully imperfect reality capable of building rocky planets, burning suns, and the heavy elements required for conscious biology. This dramatic crystallization of reality brings us directly to one of the most haunting, unsolved existential crises in modern science. When the universe was a superheated, perfectly symmetrical soup, the laws of quantum physics dictate a very specific rule regarding the creation of matter. The raw energy of the Big Bang should have produced equal amounts of matter and antimatter. For every particle of ordinary matter forged in the chaos, there should have been an exact, mirrored twin of antimatter. But matter and antimatter are fundamentally, catastrophically incompatible. When they touch, they instantly and violently annihilate one another, converting their mass entirely back into a blinding flash of pure light. As the universe cooled and the newly heavy particles slowed down enough to interact, this is exactly what happened. The cosmos became an unimaginable slaughterhouse. Trillions upon trillions of matter and antimatter particles crashed into their mirrored twins, perfectly erasing each other from existence in a deafening, universe-wide storm of radiation. By all accounts of standard mathematical logic, this war should have been a perfect tie. By the time the dust settled and the universe expanded further, the cosmos should have been completely, utterly empty. It should have been a vast, dark void filled with absolutely nothing but drifting, fading photons of cold light. There should be no galaxies spinning in the dark. There should be no planets orbiting warm stars. You and everything you have ever known should not exist. But clearly, something went wrong. A minuscule, microscopic imperfection occurred in the fundamental math of the early universe. For roughly every billion particles of antimatter, there were exactly 1,000,000,001 particles of ordinary matter. When the Great Annihilation finally ended, all the antimatter was completely destroyed, along with almost all of the ordinary matter. But that tiny, solitary fraction of a single % of ordinary matter survived the slaughter. That microscopic leftover, that mathematical rounding error, went on to become absolutely everything. Every star burning in the night sky, every galaxy caught in the cosmic web, and every heavy atom forging the cellular structure of your own consciousness is built entirely from the survivors of that primordial war. How did this happen? How did ordinary matter gain that tiny, crucial advantage over antimatter? The answer, physicists suspect, lies entirely in exactly how the Higgs field switched on. When the field fell from the top of the central peak and flooded the universe, the manner in which it fell was deeply, fundamentally consequential. Did the field smoothly and gently slide down the hill, slowly filling the valley like water calmly pooling in a quiet basin? If so, the transition would have been relatively peaceful, maintaining the delicate balance of the cosmos and providing no opportunity for ordinary matter to gain an unfair advantage? Or did the field fall violently? Did the universe undergo a sudden, traumatic phase transition? Imagine water not simply pooling, but instantly flash boiling. If the Higgs field switched on through a violent, first-order phase transition, the vacuum of space would not have shifted smoothly. Instead, the universe would have been filled with rapidly expanding, microscopic bubbles of the new, heavy reality. These bubbles of true vacuum would have expanded at nearly the speed of light, crashing and merging together, creating a roaring, turbulent shockwave across the cosmos. This chaotic, boiling subatomic turbulence could have provided the exact extreme environment needed to momentarily tweak the fundamental laws of physics. The violent boundaries of those expanding bubbles could have acted as cosmic filters, actively shifting the balance and allowing ordinary matter to gain that crucial, life-saving advantage over antimatter right before the great annihilation occurred. And what determines exactly how the Higgs field fell? What dictates whether the universe experienced a gentle, smooth slide or a violent, boiling phase transition that forged the matter we are made of? It is dictated entirely by the precise, hidden curvature of the cosmic landscape. It is determined by exactly how the invisible walls of the potential valley curve bend and warp away from the resting point. If the walls possess a certain specific steepness, the field rolls gently. If the walls bulge and curve in a slightly different mathematical configuration, the field violently boils. This is the terrifying, awe-inspiring realization that directly connects the freezing, dark tunnels of the Large Hadron Collider to the very first fraction of a second of cosmic history. We cannot build a literal time machine. We cannot travel backward 13.8 billion years to watch the newborn universe crystallize and boil. But the unyielding laws of mathematics provide us with a subtle, physical bridge across the abyss of time. The exact same curvature of the cosmic valley that determined how the universe survived its own birth is the exact same curvature that forces a single virtual ripple to tear itself in half and birth two simultaneous Higgs bosons today. By hunting for the double ripple amidst the deafening background noise of the collider, physicists are not merely trying to weigh a subatomic ghost or add a footnote to a textbook. They are attempting to mathematically reconstruct the exact steepness of the cosmic landscape. Measuring the self-coupling of the Higgs field today provides us with the precise geometrical coordinates of the vacuum. If we can successfully lock down the mathematical shape of those invisible valley walls through the rare decay of the twin particles, we can plug that exact topography back into our cosmological equations and finally run the tape of the universe in reverse. We can determine, with absolute mathematical certainty, whether the Higgs field boiled or slid. We can finally know if the very foundation of reality, the invisible ocean that gives us our mass, is also the direct reason we survived the great annihilation of the early cosmos. The stakes of this incredibly esoteric, maddeningly difficult quantum measurement are quite literally the origin of human existence. We are a species made of leftover stardust, a highly improbable biological anomaly built entirely from the debris of a broken symmetry. We navigate a world of heavy, solid objects, entirely oblivious to the fact that our physical mass is a frozen relic of a catastrophic, microscopic fall that occurred billions of years ago. Our bodies, our planets, and our civilizations are monumental consequences of a geometry we cannot even see. To grasp the true magnitude of the double Higgs experiment is to understand that the deepest secrets of our cosmic origin are not exclusively written in the cold, distant light of the ancient stars. They are woven directly into the invisible, geometric tension of the empty space immediately in front of you. The vacuum of the universe is a historical artifact, carrying the hidden scars of the Big Bang within its microscopic curvature. By desperately smashing protons together in the dark, capturing the fleeting, nearly impossible appearance of a double ripple, we are actively trying to read those ancient, geometric scars. We are attempting to prove, once and for all, exactly how the cosmic floor dropped out from beneath the universe, and why the dark, beautiful chaos of the cosmos allowed us to exist at all. We live our lives anchored by a profound, unspoken assumption of permanence. When we stand on the solid Earth, we do not question whether the ground will simply cease to exist beneath our feet. When we watch the sun rise, we trust that the nuclear furnace burning at its core is governed by laws of physics that are absolute, unwavering, and eternal. We recognize that individual things decay. Ancient stars eventually burn out, jagged mountains erode into dust, and biological life eventually fades. But we inherently believe that the underlying stage itself, the empty space where all of this drama unfolds, is fundamentally indestructible. We assume that the invisible rules of the cosmic game are fixed. But as we have plunged deeper into the architecture of the quantum realm, staring into the dark mathematical heart of the Standard Model, this comforting illusion of an eternal foundation has begun to fracture. We are completely oblivious to the fact that the laws of physics themselves might be mortal. We are forced to confront the chilling possibility that the universe we inhabit is not a finished architecture. It might simply be a temporary arrangement, a fragile, precarious configuration waiting for the inevitable moment it is allowed to collapse. To understand the ultimate existential threat hiding in the fabric of space-time, we must return to the invisible landscape that dictates the structure of reality. The Higgs field, the cosmic ocean that permeates all of existence and grants physical mass to the universe, does not rest at a value of zero. In the blistering aftermath of the Big Bang, the universe cooled, and the field sought the lowest possible energy state. It rolled down a mathematical slope and settled into a deep, circular trough. That trough represents our vacuum. It is the baseline of our reality. Because the field rests at that specific, non-zero depth, the fundamental particles possess the exact mass they do. Because the particles weigh exactly what they weigh, heavy atoms can form, molecules can bind, and the intricate, delicate chemistry required for biological life can flourish across the cosmos. Everything you have ever known, every rocky planet, every burning star, and every conscious thought is entirely dependent on the Higgs field remaining perfectly still at the bottom of that specific valley. For decades, physicists naturally assumed that this valley was the absolute bottom of the cosmic landscape. We believed it was the true vacuum, the final, inescapable ground state of the universe where no lower energy level could possibly exist. But the mathematics governing the quantum world are notoriously indifferent to human comfort. When physicists began to calculate the complex interactions between the Higgs field and the heaviest known particles in the universe, a terrifying anomaly emerged in the equations. The shape of the cosmic landscape is entirely dictated by the field's self-interaction, the precise way it pushes and pulls against its own presence. And our current measurements, born from the violent subatomic collisions deep beneath the Earth, suggest a deeply unsettling topography. The valley we live in might not be the absolute bottom. If you were to trace the invisible walls of our valley further out, away from the resting point of the field, the mathematical curve appears to rise into a small, precarious hill. But it does not continue to climb. Instead, just beyond that peak, the landscape plunges violently downward, descending into a secondary, unfathomably deep abyss. A true vacuum. If this theoretical topography is correct, it means that our universe is completely metastable. We are not resting on the solid, permanent floor of existence. We are sitting on a temporary ledge. The heavy, solid reality we experience every single day is essentially balancing on a mathematical cliff, prevented from falling into the absolute dark only by the presence of that small, separating hill. In the classical, macroscopic world, sitting in a valley behind a hill is a perfectly safe and reliable arrangement. A physical boulder resting in a depression will stay there forever unless a massive injection of external energy forces it up and over the peak. By classical logic, the universe is perfectly safe from the abyss. But the Higgs field is not a classical object. It is a quantum entity, and it is governed by the chaotic, hallucinatory rules of subatomic mechanics. In the quantum realm, Particles and fields do not always need enough energy to physically climb over a barrier. Because of the inherent uncertainty woven into the fabric of space, a quantum system can simply bypass the physical barrier entirely. It can disappear from one side of an impenetrable wall and spontaneously reappear on the other. This phenomenon is known as quantum tunneling. It is not a theoretical abstraction. It is a very real, heavily documented mechanic of the physical universe. It is the exact process that allows stars to ignite and burn, permitting protons to fuse together in the stellar core, even when they fundamentally lack the kinetic energy to overcome their mutual magnetic repulsion. This means that the Higgs field does not need a catastrophic cosmic event to push it over the edge of the hill. At any given moment, in any random, isolated millimeter of empty space across the infinite expanse of the cosmos, the field could simply tunnel through the barrier. It could spontaneously slip through the mathematics and drop into the deeper, darker abyss of the true vacuum. If that happens, it triggers the ultimate, inescapable catastrophe. It flips the doomsday switch of reality itself. It initiates a phenomenon physicists call vacuum decay. The exact moment the field tunnels into the deeper valley, a microscopic bubble of true vacuum is born in the dark. Inside this tiny, expanding sphere, the fundamental rules of the universe are completely rewritten. Because the Higgs field has dropped to an entirely different resting value, the mass of every fundamental particle inside the bubble is instantly and radically altered. Electrons might suddenly become wildly heavy or entirely weightless. The delicate, mathematically perfect balance of the strong and weak nuclear forces is completely shattered. The immediate consequence of this shifting architecture is absolute atomic dissolution. Matter simply cannot exist under the new mathematical regime. It does not simply break the matter, it deletes the very rules that allow matter to hold a physical shape. Inside the bubble, chemistry is a physical impossibility. The atoms holding together the planets, the stars, and the complex biological structures of life instantly unravel, dissolving into a chaotic, unrecognizable spray of raw, alien energy. And this bubble does not stay microscopic. The true vacuum is a much lower energy state, which means the boundary of the bubble is incredibly violently driven outward by the pressure of the false vacuum collapsing around it. It expands across the cosmos in all directions at exactly the speed of light. There is a chilling, almost merciful elegance to the physics of vacuum decay. Because the wall of destruction expands at the absolute speed limit of the universe, no warning signal could ever precede it. You cannot see something approaching at the speed of light, because the light carrying the visual image of the destruction arrives at the exact same instant as the destruction itself. If a bubble of true vacuum originated in a distant, ancient galaxy millions of years ago, and its expanding wall reached our solar system tonight, there would be no alarm. The night sky would not change. The stars would not slowly flicker out. The warning systems of our civilization would remain perfectly silent. In one blinding, measureless fraction of a microsecond, the Earth, the Sun, and the entire architecture of our local space would simply cease to be. The bubble would pass through our world, instantly rewriting the laws of physics and erasing every physical trace of human history, every monument, and every memory, without a single moment of pain or awareness. The universe would not end in a blaze of fire or a slow freeze of ice. It would simply transition into a new, cold, and utterly alien state of existence, permanently hostile to the complex structures of life. This apocalyptic scenario sounds like the realm of dark science fiction, but it is a direct, terrifying consequence of the equations that successfully built the modern technological world. It is the dark shadow cast by the Standard Model, and it brings into sharp, breathtaking focus the true, existential stakes of the incredibly complex experiments being conducted deep beneath the European continent. When physicists sift through the chaotic, deafening subatomic debris of the Large Hadron Collider, desperately hunting for the impossible appearance of a double ripple in the Higgs field, they are not engaged in abstract particle classification. They are trying to measure the exact thickness of the ledge we are standing on. The rate at which the Higgs field produces twin bosons is the only direct, physical key we possess to unlock the true shape of the cosmic landscape. By measuring the elusive self-interaction of the field, we are mathematically calculating the exact curvature of the valley walls. We are attempting to verify, with hard data, if the landscape eventually slopes downward into an abyss, and if so, exactly how thick the separating hill truly is. We are trying to determine if the probability of vacuum decay happening tomorrow is essentially zero, or if it is a silent, creeping inevitability ticking away in the dark. Current measurements, derived from the mass of the single Higgs boson and the incredibly heavy top quark, place our universe in a profoundly unsettling location on the graph of probability. We do not appear to sit comfortably in a zone of absolute stability, nor do we sit in a zone of rapid, immediate collapse. Instead, the mathematics suggest we are perfectly, delicately poised right on the boundary line. We are balancing on a cosmic knife edge, existing in a state of extended metastability, where the universe is stable enough to allow billions of years of complex evolution, but fragile enough to eventually, inevitably succumb to the dark. This delicate balancing act forces us to deeply rethink our place within the vast, indifferent mechanics of the cosmos. For centuries, we have sought to conquer the natural world, believing that through intellect and engineering, we could secure a permanent, untouchable foothold in the universe. We build towering civilizations designed to outlast the millennia, and we dream of expanding our physical presence across the stars. We possess an undeniable, biological urge for immortality, both as individuals and as a species. But the silent, invisible mechanics of the quantum vacuum effortlessly strip away this arrogance. They remind us that we are not the masters of reality. We are temporary guests, biological patterns dancing on a thin, freezing layer of ice over an infinitely deep, dark ocean. The very physical laws that grant us our existence are not eternal decrees passed down from the heavens. They are a localized, highly specific set of environmental conditions that can be violently revoked by the blind, probabilistic roll of the quantum dice. Yet, there is a profound, almost overwhelming beauty to be found in this extreme fragility. If the universe is truly metastable, if the ground beneath all of existence is destined to eventually give way and fall, it does not render our lives meaningless. In fact, it accomplishes the exact opposite. It elevates the sheer improbability of our existence to something truly miraculous. Against the staggering, indifferent forces of the cosmic dark, against the looming, ever-present mathematical threat of quantum annihilation, the universe managed to hold its breath long enough for stars to ignite, for heavy elements to forge in the hearts of supernovas, and for conscious minds to eventually awaken. Out of the absolute chaos of subatomic interference and boiling quantum fields, a physical structure arose that was stable enough to eventually look back upon itself, to build massive, superconducting machines in the freezing dark, and to decipher the very rules of its own precarious existence. We are made of trapped energy and borrowed time. Every single moment of human experience, every act of scientific discovery, every expression of love, and every quiet night spent looking up at the sprawling architecture of the stars is a direct consequence of a delicate, temporary balance in an invisible field. We do not need the universe to be eternal for it to be magnificent. The undeniable fact that the cosmic stage might one day collapse makes the current performance infinitely more precious. The relentless hunt for the twin ripples continues, standing as a testament to our unyielding need to know the fundamental truth, no matter how terrifying or unsettling that truth might be. We are reaching into the absolute darkest corners of reality, daring to ask the indifferent cosmos if the ground we stand on is a permanent home, or merely a beautiful, fleeting illusion waiting to be erased. Good night, and see you in the next video.